Look into my eyes.
We hear a lot about AI. How does Flir use AI in its products?
Yeah, so that's a very interesting question. In fact, AI is a very general term. We now use it mainly for, let's say, for mentioning or we are referring to deep neural network models that are trained by a lot of data, a lot of images. But AI means, in fact, artificial intelligence. And if you're going back in history, then in 1979, when we started to, let's say, to interpret one pixel of an image, that was the moment that we start to use AI. So let's say that AI is a very broad term, but like I already mentioned, most of the people that are now using the terminology AI are in fact referring to deep neural networks. So what Flir does in that respect is, first of all, we have still our experience and algorithms over the last 30 years, since 1992, so more than 30 years. But we are now also having the deep neural network models trained by our by the vast amount of images that we already collected over all those years. So we can combine best of both worlds. Important to mention is we are doing AI inside our cameras and our sensors. We are not using, for example, an external computer. We are not using the cloud in order to learn better the different models. We are, let's say, we have chosen to do that inside the camera because it has a lot of advantages. The first one is the speed of detection and the speed of output of the detection. In some, let's say, technologies or some markets, we need to give in less than 0.1 seconds a new status update of the traffic moving. That's, for example, at intersections, if you want to emulate groups. So you have to be extremely fast. Then the second thing is you don't want to be harmed, or at least you don't want to have errors in the transmission of your video towards your detection device. So that is the second reason. Third is you want to be completely cyber secure. If everything is in the same housing, then it's much easier to cyber secure your solution. Also for privacy concerns, it's better that we keep everything internal and that only in case that the customer wants, we are exporting the data. We can export also let's say the camera images, but it's only if the customer really prefers to do that. So it has really a lot of advantages to have everything inside the camera. So you don't have to worry about cybersecurity or anything like that. That's already one thing that I want to mention. Now let's maybe go into the way how we are using the latest DNN models, how we are training them, so that at least you have an idea about the advantages that we are offering with this detection system, but also what we offer more, because it doesn't stop just at the deep neural networks. So first of all, like I already mentioned, the good thing about Flir is that we already have an experience of more than 30 years, and we have video recordings of more than 30 years that really help us to train these models in an excellent way. That is the first thing that is important when you are using DNN models inside your devices. So what we are actually doing is, with the DNN model, which is simulating what a brain actually does, we are going to capture these images and we are going to deduct, okay, is this a vehicle or a pedestrian? What type of vehicle is it? Is it a car? Is it a van? Is it a truck? Is it a bus? So dependent on, let's say, your video base and all the videos that you can train your model to have different classes of vehicles, also your pedestrians and your bicycles. And like mentioned, we do that in the same housing, just next to the camera, processing inside, and we run everything locally. So that's the idea about how we're using DNN in our systems. Now, the thing is that what you can see is, for example, here, the classification happens with the DNN, but we are going a lot further than that. We also are going to start to track them. We can actually say from every vehicle, from every pedestrian person, at what speed it is arriving, what is the localization of that vehicle or Volvo road users. So we can start counting the vehicles in front of an intersection. We can see if they're doing some strange movements, so that can provoke or that can be dangerous. We can start to see near misses between the different actors in traffic. So let's say it's offering a lot more than the classical video detection could do. So we are not only going to classify, which is typically DNN, but we're also going to track. And with that tracking together with the classification, we can actually do quite a lot of things. So if we're looking at it, like mentioned, position, heading, speed, together with the classification, we know exactly where each of the objects are. We can predict, we can follow them, we can have the trajectories. In fact, all those trajectories can be saved into our management system for later use. To use, for example, trajectories to calculate near misses, illegal U-turns, those type of dangerous things that maybe for certain intersections you need to find a solution for. And everything is, like already mentioned, embedded into our sensors. So if you're going further, this is another example. This is like you can see with the visual camera. We still have the thermal and visual next to each other, dependent how the customer wants to use the system. If it's more, let's say, for data collection and all that, well, then visual can be perfectly fine. If it's safety critical, especially with vulnerable road users, and you want to detect 100% of the time, day and night, in all weather circumstances, then we recommend thermal. But so for every customer, we have a solution, both in visual and in thermal. This is an example of our visual solution. Like you can see, you can perfectly measure or see all the vehicles that are waiting, at what kilometer per hour they are driving. So it's giving you a lot of information that previously we were not able to do before that we were using these DNN models. If you combine everything together, then we can also represent in a different way. We know from each vehicle exactly where it is driving, what is the GPS localization, and by doing that, well, we can actually also put on the Google Maps, because that obviously knows exactly GPS localization as well. So we can then map all those different objects onto this, let's say, intersection on Google Maps. It's just to give you a better idea about what we mean when we say we do localization of our, let's say, of our objects and all the things that you can do with it. Making digital twins, like already mentioned before, digital twins can be extremely interesting when using together with V2X. So all of that is now possible with our sensors.